Hello, welcome to video 9, Price Elasticity of Demand, PED. You know, I put videos up on YouTube before, about 65 economics videos. The videos on price elasticity of demand are by far the most viewed videos, and that tells me that this is where students have the most difficulty. So let's go through price elasticity of demand. We'll start with the definition. Price elasticity of demand, or PED, is a measurement of the responsiveness of quantity demanded for a good following a change in the price of that good. Okay? And what price elasticity of demand is not, and this is where some of the confusion starts, is it is not a tool for telling us whether quantity demanded rose or fell. We know that anyway. Quantity demanded always changes in the opposite direction to price. If price rises, quantity demanded will fall. If price falls, quantity demanded will rise. That's not what PED is about. PED tells us how much quantity demanded changed relative to the change in the price. Sometimes price can change quite a lot, and the quantity demanded of the good barely changes. Think of the example of electricity. Electricity could double in price tomorrow, but we would barely reduce the quantity demanded of electricity that we purchase. We wouldn't like the fact that the price has doubled, but we need electricity, and we might be a bit more careful about how we use electricity. We might turn off the lights when we leave a room. We might think about switching off air conditioning more to save money, but we wouldn't reduce very much the quantity demanded of electricity. But even so then, the price went up and the quantity demanded fell a little bit. PED would tell us how much, relative to the price change, the quantity demanded fell. And in the case of electricity, it's probably, we say, quite inelastic demand. Now, there are two ways of measuring PED. There's two equations, because we can place a value on PED. The demand for a good, by measuring how the quantity demanded changes when the price changes, we can place a value on that price elasticity of demand measurement. And there's two equations by which we could do it. P over Q times change in Q over change in P. That will give us the PED value, or percent change in quantity divided by percent change in price will also give us the PED value. And I've got an example here where we can actually go through the calculations, and I can show you how we reach a value for PED. So an example question: a kilogram of cheese rises in price from $8 to $10, and quantity demanded falls from 10,000 to 9,000 units. Let's work through this. I'm going to use the first equation, first of all. P over Q times change. Delta is change. Change in Q over change in P equals PED. Well, I'll rewrite that with all the numbers that I know. The original price was 8, the original quantity was 10,000, times the change in quantity. Well, the quantity went from 10,000 to 9,000, so that's minus 1,000 divided by the change in the price, and that's plus 2, because it went up $2. Now if I calculate this out, well, I can do some simplifying. I'm going to cross out those 3 zeros and those 3 zeros there, and I can even simplify here, can't I? So let's say that's 4, and that becomes 1. So I've got 4 times minus 1 is minus 4 over 10 times 1 is 10. So I can see that the PED is minus 0.4. Okay? Now, I can also use the other equation. That's the answer, let's not forget that. Now, I can also use the other equation to calculate this. And the other equation was percent change in quantity divided by percent change in price equals PED. So, the percent change in the quantity. Well, the quantity fell by 1,000 from a start of 10,000. The percent change in quantity is 10%. So percent change in quantity is minus 10% because it fell at 10%. And the change in the price, it went up 2 it went up $2 from $8, so the price went up 25%. Oops. So it went up 25%, which again comes out to 0.4 negative 0.4. So either way we calculate, we reach the same answer. You can use either of those equations, and sometimes in questions you're going to have to use the second equation because you won't know any absolute values like $8, $10. You'll only know percentage changes. That forces you to use the second equation. So you can pin a value on these PEDs, and as a consequence, we need to be able to interpret the PED values. Now, to be able to understand these PED values, we need to be able to interpret what the numbers mean. And I want to look at these values, although I should say that because PED values always come out as negative, sometimes we ignore the negative. Now, we shouldn't, but for the time being, I'm ignoring the negative. So, if the answer of PED comes out as 0, which is unusual, it means that the demand is perfectly inelastic. That means that any change in price leads to no reaction in the quantity demanded. Whether there are any goods like that in the real world, we don't know. But possibly, theoretically, it's possible. So, perfectly inelastic demand would have a PED value of 0. If the PED value lies between 0 and 1, ignoring the negative for the moment, if it's between 0 and 1, we say that the demand is inelastic. Inelastic demand means that the quantity demanded of the good reacts by a proportionately smaller amount than the price changed. Whatever the size of the price change, as a proportion of the price, the change in the quantity demanded will be smaller. If PED comes out as 1, we say the demand has unitary elasticity. That means that the demand changed by the same proportion as price changed. If price rose 6%, quantity demanded fell 6%. If it's above 1, we say elastic demand. The demand reacts by a bigger proportion than price changed. Quantity demanded changed by more, proportionately speaking, than the price changed. And another extreme, like the 0, is if PED is infinity. We say the good has perfectly elastic demand. The quantity demanded reacts as much as it possibly could. That means that this tiniest price change leads to a complete change in the quantity demanded. If the price goes up ever so slightly or down ever so slightly, all of the quantity demanded disappears. There is no demand at all except at that particular price. It's the ultimate in responsiveness to a change in price. Okay, the two extremes are that. They are extremes, but the most important ones are the inelastic and the elastic demand. 99.99% of goods will have demand that is either elastic or inelastic. Okay, let's take a couple of examples. Imagine good X has, we learn, a PED of -2. Now I am being good here because I'm including the -2, the minus in the -2. What does that mean? Well, it's above 1, and it's in that range of elastic demand. It literally means that when when price changes by X%, the quantity changes by 2X%. This 2 is the size of of how much the quantity demanded is magnified from the price. And 2 means twice as big. So whatever the size of the change in price, that's how big the quantity demanded changes times 2. If the price goes up 10%, quantity demanded falls by 20%. If the price goes up by 3%, quantity demanded falls by 6%. If, however, the PED is -0.1, it's clearly inelastic demand, and it's very inelastic. the change in the quantity demanded will only be 0.1 the size of the change in price. If the price changes 10%, quantity demanded only changes 1%. For example, electricity. Perhaps if the price of electricity went up 10%, we would only see a 1% drop in the quantity demanded. Okay? Now, there is a rule we must know when it comes to PED. Straight line demand curves, straight line or linear demand curves, whatever the gradient, if the demand curve is a straight line, the following must be true. At the point where the demand curve touches the price axis, here, PED is infinity, it's infinite. And here, where the demand curve cuts the Q-axis, PED is 0, perfectly inelastic. And at the midpoint, PED is 1, minus 1 actually. Why is that? It must be so, because if you think about that equation, P over Q, remember the equation, P over Q times change in Q over change in P, equaling PED. If you think of that equation, at that point where it touches the P-axis, quantity is 0. We have not moved along this axis. So the bottom line, here, the Q, the bottom line of this equation will equal 0. So the final answer must be divided by 0, and that's infinity. And here, it must equal 0, because at this point, price is 0. We have no height on this axis. And if the top line, if P is 0, then the whole thing must calculate to 0. So this shows us that on straight line demand curves, elasticity falls from infinity to 0 and is 1 at the midpoint. And it means that the top half of any demand curve is elastic. And the bottom half of any demand curve is inelastic. And that is useful for us later, especially in the second year when you learn about revenue, the second year of A-level when you learn about revenues, that becomes very useful. This only happens with straight line demand curves though, whatever the gradient. Okay, let's move on. So, what characteristics of a good determine its PED? A good is likely to have inelastic demand. Let's look at it that way. What kind of goods would have inelastic demand? A good's likely to have inelastic demand if it's a necessity. That's the argument with electricity. Has to be bought, so if it's a necessity, not a luxury, it's likely that price changes won't affect our demand very much. So if it's a necessity, if it has no substitutes, no alternatives to use, if expenditure on it is small as a percentage of total spending. Let me give you an example of that one. Imagine a large company that spends an awful lot of money on raw materials and labour and land and various vehicles and buildings and rent and electricity, and amongst all of that millions and millions of dollars of spending, it even buys paper clips because the office needs paper clips. Well, it gets through some boxes of paper clips every year, and the boxes cost $1 each. If the price of the paper clips doubled to $2 each, a 100% price rise in paper clips, of course the business would just carry on buying the same amount of paper clips as before, because it's so insignificant within their total spending. So if the spending on an item is insignificant as a proportion of total spending, it reduces the elasticity, it makes it more inelastic, maybe even perfectly inelastic demand. Finally, over a short time period, the shorter the time period under consideration, the more inelastic is the demand. If the price of motorbikes dropped to €1, imagine that, all motorbikes dropped to €1. Well, that's still not a very good example. Hang on. Finally, over a short time period. Let me give you an example of that. In my house runs on electricity. I use electricity to heat the water, I use electricity for the central heating, not gas, electricity. Now, if the price of natural gas fell dramatically tomorrow, would I simply stop demanding electricity and start demanding natural gas? No, because it would take a long time to refit my house in order to be able to make use of the very cheap natural gas. Now, gradually over time, if you look over 10 years, there'll be lots of households who need to upgrade their house, and at that moment they choose to go to natural gas. But in the very short term, in one day or 1 week, of course, houses don't rip out their electricity central heating systems and install gas ones, just like that. It's a big decision. So the shorter the time period under consideration, the more likely a good is to have inelastic price elasticity of demand. Okay. Now, the reverse is true, of course. For a good, it's more likely to have elastic demand if it's a luxury, if there are many substitutes, if a large amount is spent on the good, and the longer the time period. How is consumer spending and producer revenue affected by PED? When the price changes of a good, we know if the price rises, people buy less of a good. But do they spend more or less? That depends on elasticity. When the demand for a good is elastic, if the price rises, quantity will fall and spending will fall. You see, the reaction of the consumers of how much they spend, how much they buy, outweighs the change in the price, the rise in the price. There's such a large drop, if it's elastic demand, this is proportionately bigger than this. So there's such a large drop in the quantity being sold that if the price were to rise, the larger drop in the quantity demanded means overall spending by consumers falls and producer revenues fall. So the message is, if you're selling a good where there's elastic demand and you want to bring in more revenue, don't raise the price. Likewise, if the price falls, there's such a large rise in quantity being bought that actually spending can rise. The extra spending by consumers on all the extra goods they're buying outweighs the drop in the price. The reverse is true if the good has inelastic demand. If the price rises, although the quantity falls, it doesn't fall by very much, and so spending overall rises. Fewer are being bought, but overall more is being spent, because the drop in the number being bought is not as much as the rise in the price. Finally, when the good has inelastic demand, if the price falls, yes, the quantity rises, but not by very much, by a proportionately smaller amount than the price fell. Consequently, spending falls. This idea just has to be learned and is at the basis of many A-level questions. So it really must be learned. It might seem counterintuitive that you can cut your price and get more money. A producer really can cut the price of the good they're selling, but earn more money, because if the good was elastic demand, they would sell so many extra goods that they earn more revenue. And that can kind of lead to a question, because once a bright pupil of mine asked me, well, you know, if this is the case, if I know I'm selling a good that has inelastic demand, you know, why don't I just continually raise my price? If I continue to raise my price, I can get people to spend more and more and more money according to this. Or, put another way, if I'm selling a good with elastic demand, no, let me cut this as well. Let me cut this and start this little bit again. Okay. What I want to say is that. Now this leads to an interesting point, which is this. Why is it not possible to, if you are selling a good with inelastic demand, why not continually raise your price? If you keep raising your price, you should earn more and more and more revenue. But I can show you that that's not true by going back to what we said about straight line demand curves. Let's say that at the moment the price is here, and this is the quantity being sold. Price 1, quantity 1. I can even put some numbers on this. Let's say that the price really is 1 and the quantity is 10. So clearly the revenue being earned is 10 units being sold at $1, let's say, dollar each, so the revenue is $10. Okay? And they put the price up to 2. And now they're only selling 9. Well, now you can see that the revenue is $18. They boosted their revenue. The consumers spent more because the rise in the price, that was a doubling in price, but they only dropped 10% in the quantity demanded. Very inelastic demand. So this firm's revenue went from 10 up to 18 by raising their price. They will be encouraged to raise their price and raise their price and raise their price. But there comes a point when they go beyond the midpoint. And at that point, the demand tips to being elastic. And they can no longer raise their price and expect to increase revenue. Just to take it to an extreme, if the price is 9, let's say, and the demand is 2, you see that the revenue is 18. If they put their price up to 10 and they only get 1 sold, the revenue has dropped to just 10. Price of 10, 1 sold is 10 revenue. So that you can see that the firms selling inelastic goods, if they continue, inelastic demand goods, if they continue to raise their price, thinking that they can just collect lots and lots of extra revenue, there comes a point when they've raised their price so much that they're then in the top half of a demand curve, and the demand is now elastic. And they can no longer achieve rises in revenue by continually raising their price. Okay, so I hope that's covered all the points in this big topic of price elasticity of demand. You should not be afraid of price elasticity of demand. You shouldn't be hoping it doesn't come up on a test or it doesn't come up on the exam. Firstly, it will come up on the test or the exam because it's incredibly important. But secondly, you should try and view price elasticity of demand as a tool which is used by economists, because you're an economist, it's used by economists to explain what's happening. One pupil once came out of an exam where I was, and I was waiting anxiously, and out came the pupil from the exam, and I said, "How did it go?" Not a very strong pupil. And he said, "Oh, it was great, it was easy. Elasticity didn't come up." And I kind of smiled, but inwardly I was groaning, because I knew that the questions may not have named elasticity in the questions, but I knew that they wanted the student to use the concept of price elasticity of demand within their answer. You've got to make use of this. You've got to try and bring this concept in to your discussions of economics and market forces, because it's so important. And one final point, never do what I often do, which is say, oh, you know, coffee is inelastic, cars are inelastic, electricity is inelastic, apples are elastic. It's not the good that's elastic or inelastic, it's the demand for the good that's elastic or inelastic. You must say coffee has inelastic demand, or the demand for coffee is inelastic. You cannot say coffee is inelastic, it's a mistake. It's easy to do that by mistake, but remember, the good is never elastic or inelastic, the demand for the good is. Okay? Thank you for watching. See you next time. Bye bye. Stop.